In order to solve these equations, we have to focus on the fraction at some point, and in this video I'm going to show you when to prioritize eliminating that fraction. So looking at number 1, we have a fraction being subtracted with a whole number, and on the other side of the equal sign we have another whole number. We want to combine like terms before we attack the fraction. So we're going to add 4 to both sides, and again, I covered this in a previous video. Check that out on the channel if you need help with simple equation solving. Now we can focus on the fraction now. We have x plus 2 over 3 equals positive 3. At this point, we should focus on getting rid of the denominator in the fraction. That should be our top priority. Don't get caught up in whatever is in the numerator. We could eliminate that denominator by multiplying both sides by whatever the denominator is. In our case, our denominator is 3. So we want to multiply that to both sides. So we will have x plus 2 equals 9. Again, the denominator will just essentially disappear from the left hand side because we multiplied this fraction by 3. And so those 3's will cancel. If we do a little multiplication here, they cancel. So now we could refocus on this left hand side. We could subtract 2 to both sides, giving us x equals 7 as our final answer. Alright, now let's focus on a equation where we have multiple fractions. This is doable in the same process that we did the first problem. We could add both sides. We could add 4/3 to both sides, and it will give us a nice whole number. We are going to get, let's see, negative 1/3 plus 4/3 is a positive 3 over 3, which is 1. This is great. However, fractions don't always work out that way. And so I want to teach you a method that you can use with any fraction. Any situation where you have multiple fractions in an equation, we can eliminate all the fractions in one step. And we could do so by multiplying both sides of the equation by the LCD, the least common denominator. Now for this problem, I made it pretty simple. The LCD in this situation is 3. So our LCD is 3. That's going to be the number that each of the denominators across the entire equation go into, the smallest number that they all go into. Now they all match, so that's pretty easy. This is what it looks like. We will have 3 and then times the entire equation. Now this looks kind of complicated, but essentially all you're doing is you're focusing on the number that we're multiplying to each of the denominators. And so we have 3 over 3, those cancel, this 3 is going to cancel, and then the other 3 on the other side of the equal sign is also going to cancel. We have to basically distribute the 3 to each of these fractions. Don't multiply it out to the numerators. You could get by doing this, but you're adding more work on your plate. Alright, you're doing way too much work there. And little errors do happen. No matter how good you are, you can always make a small error. So I'm going to rewrite this equation one more time, but I'm going to have done multiply the equation by 3. So we're just left with x plus 2 minus 4 equals a negative 1. Okay? And so now this equation is so much easier to tackle. So we could combine the 2 and the 4, give us x minus 2 equals negative 1. And now I could add 2 to both sides. So x equals a positive 1. Alright, so for this other problem we have up here, it's a little bit different. We have different denominators. This is a more realistic example that you'll see on a test. So first, let's identify that we have fractions across the board. We want to eliminate the fractions. And our LCD is what? What do you think the LCD is? A trick for finding the LCD is to multiply 2 of those fractions and then see if that is a number that the other fraction, the other denominator, can go into. So we could do 3 times 5. We know that that's 15. And also our other denominator is also 3. So 3 does go into 15. Alright, so we can identify that 15 is our least common denominator. Continuing with this, we want to multiply that across. Again, it seems like a big number, but don't actually apply it to the numerators. I want to go over this technique again, because once you get good at the simplification here, this math becomes really, really easy. This 15 is going to cancel with the 3. Let me use my blue marker. So the 15 and this 3 down here, down below, it's going to cancel. Okay? 15 divided by 3 is 5. So we can have 5 times x plus 2. No fraction. We got rid of that denominator. It's basically just over 1. And we don't have to write that. So I'm done with that denominator. I'm done with that fraction basically. Continuing over here to the other term, we have the 5. And then so we have 15 divided by 5 is 3. Now we have a minus sign. Don't forget that minus sign, guys. 15 divided by 5 is 3. So we have 3 times the 4. You see? And the denominator is completely gone. And now we have the 15 and the 3 on this side. So we have a negative 5 times 1. Okay? Or 5 times a negative 1. It's the same thing, no matter which one you put the negative sign on, which number. All right, now, looking at this is much easier to handle. Let's distribute the 5. We have 5x plus 10 minus 12. That's the 3 times 4, and then is equal to a negative 5. We could add 12, or actually we could combine the 10 and the negative 12. So it's 5x minus 2 equals negative 5. We can add 2 to both sides. Oh, I think I'm off the board. Yes. All right. Let's see. I'll carry it out over here. 5x minus 2 equals negative 5. Add 2 to both sides. We get 5x equals a negative 3. And to cancel that 5, we have to divide both sides by that coefficient, by that number 5. So x equals a negative 3/5. Again, we can really accelerate the process after we've eliminated the fractions. That's what makes it much easier. All right, so continuing on, we have some more problems. Let's see what happens when we have a variable inside the denominator. Let's see how that changes the problem. 6 over x plus 1 minus 5 equals 7. Okay, so my first step is to combine like terms. You always want to combine like terms any moment you can. So we're going to add 5 to both sides. Notice that the 5 isn't even in a fraction, and neither is the 7. We could combine those very easily. So now we're left with 6 over x plus 1 equals 12. Okay, but now what? So if you heed to my advice earlier, I said eliminate the denominator, or eliminate any fractions, by multiplying by the denominator. And so our denominator, it isn't x and it isn't a positive 1. The denominator is x plus 1. So we could take x plus 1 and we can multiply it by the entire equation. Don't panic. Check this out. All right, remember that technique we were just practicing where we could cancel the term we were multiplying by the denominators? Well, the x plus 1 over x plus 1 would cancel entirely. Okay? They would completely disappear. There's no FOIL you have to do. There's no crazy factoring or simplification. So on the left-hand side, we're just left with 6. Now, that x plus 1 does get multiplied, however, to the 12. So we would have 12 times x plus 1. All right? Which isn't too crazy. All we have to do is distribute that 12. 6 equals 12x plus 12. And then subtract 12 to both sides. We get negative 6 equals 12x. Let me see. Yep, just there. So divide both sides by 12, you get x equals negative 1/2. Okay. So even if you see a denominator with a variable or multiple variables, multiple terms, don't panic. Just follow the rules that you know and practice that simplification technique that I'm teaching you. It makes life a lot easier. Let's do 2 over 3x plus 2 equals 1/2 plus 2/3. This is interesting. So we do have multiple fractions, so we know we have to use an LCD of some sort. But in this case, what is the LCD? The LCD is not just the 3x plus 2. It's more than that. We have a fraction over here on the right-hand side of 2, and then we also have a fraction with the denominator of 3. We have to take that into consideration when we determine the LCD. I know that 3 and 2 are already in here in this group, but that doesn't mean that they just kind of blend in. You have to include them. And we include them by multiplying. Remember what I said about the fraction that had the 3's and the 5's? The problem that had 3's and 5's as a denominator? I said you can multiply the denominators to find the LCD. Whoops. Remember we did that problem? It's the same concept. I know it's a little bit trickier because we have a variable, but don't panic. You just got to multiply all of the LCD or all of the denominators together. So it doesn't look pretty right now. Let's go ahead and simplify this before we continue. Actually, let's keep this separated. I want to keep this separated so that you can see what happens when we multiply it out across the entire equation. So we're going to have 3x plus 2 times 2 times 3 all times our equation. Alright, so understand that we have to focus on these denominators and canceling them out with something. Now the 3x plus 2's match, so those cancel out. But what do I do with the 2 that's up in the numerator? Do I just put 2 equals and I'm done? No. You have to consider the remaining pieces, if you will, the remaining numbers that we did not cancel out. So for this first fraction, we only canceled out the 3x plus 2. We still have to consider the 2 and the 3. Now before I continue, we can simplify this pretty quickly. We get 6 times 2, right? 2 times 3. And then we get 12. So I'm actually going to erase all that and just put 12. 12 equals. All right. Now moving on to the next fraction. We have a 2 down below. And that's only going to cancel with this middle term. So what's left over? The 3x plus 2 is left over. And then the 3 is left over. So we have 3x plus 2 times 3, right? These are the pieces that are left over that we couldn't cancel when we're dealing with this fraction. And then we have to multiply that by 1. Remember, that's the numerator. All right. And now for the last fraction, we have plus. The 3 is going to cancel. And in this case, we're left with the 3x plus 2 and the 2. So we get 3x plus 2 times 2 times another 2 because the 2 is up top in the numerator. All right. 12 equals. We can multiply some of these things out. Notice that the 3 and the 1, let me use my black marker for this. The 3 and the 1, that's just basically just 3. And so we just have to distribute the 3 over. So we get 9x plus 6. All right, so even though it looks hard, that's what it simplifies to. And then we have the plus sign here, transferring the plus sign. And now we have 3x plus 2 times 2 times 2. So that's 4 times 3x plus 2, which can then be rewritten quickly as 12x plus 8 if you distribute that 4. And I hope you can see all the moments where you could do some math in your head and not have to write it out like I am. But I want you guys to visualize every step that's happening. All right, so now we can combine like terms. We have 12 equals. Let's see, we got the 9x and the 12x. That's going to give me a 21x. And then we have the 6 and the 8. That's a plus 14. Now we can solve for x. Minus 14, negative 2 equals 21x. Divide by 21. We get x equals a negative 2 over 21. I know this one's a little bit harder because of how awkward it was, awkward LCD that we had. But I hope you can see the method that we're using and how it actually transfers from easy problems to difficult problems. All right, moving on. Let's see. Let's do 7x minus 3 over 5x plus 5. This one's a little bit different. Over 2 over 5. All right, so by all means, you can use the LCD method that we're practicing. I am going to show that briefly, but I also want to cover a specific method that we could use when we have two fractions equal to each other. So let's go over the LCD method that we've been practicing first. The LCD would be 5 times 5x plus 5. When we apply that to both sides, all right, when we apply that in the first fraction, the 5x plus 5's cancel, so that gives me 5 times 7x minus 3. Okay, so that first fraction simplifies to just this expression right here. The second fraction, the 5's cancel, so then we have 2 times 5x plus 5. Continuing on, we go to distribute, combine like terms. You get x equals 1. I did that pretty quick. Hold on, let me double check. Subtract the 10x, add the 15. Yeah, we're looking good. X equals 1. If you're comfortable with this method, stick with it, all right? Just use it every single time. Every single time. When you have fractions, eliminate those fractions. Use the LCD to eliminate those denominators. All right, I want to show you a tip. Just in case you're not vibing with the method here today so far, when you have two fractions that are equal to each other, and it's just fractions, you could do something called cross multiply. You could do something called cross multiply. When you cross multiply, you're going to take the denominator of one side and multiply it to the numerator of the other, and vice versa. So we have 5x plus 2 times 2 equals 7x minus 3 times 5. And it doesn't matter which side you put the groups on. If you want to put the 7x minus 3 times 5 on the left hand side, you could do that, as long as you put the other pair to the right side, okay? This seems like such a easy shortcut. You might wonder why I didn't just teach this. Again, this only occurs when you have two fractions equal to each other, okay? All right, that's the only case. Now, in all those other problems that we did, you did notice that we had some other terms involved. Like, it would be a over b plus 3 equals x over y. Okay, you cannot cross multiply in a situation like that. Only in a situation where it's just two fractions set equal to each other. So, moving on, let's finish this up. We could do 10x plus 4 equals 35x minus 15. Wait a minute. Oh, I put 5x plus 2. I'm sorry. Guys, it's 5x plus 5. My bad. So that's 10x plus 10 equals 35 minus 15. Yep, we got 10x equals 35 minus 15 minus 10. 10x equals, let's see, that's 20. And then minus another 10, that would be 10. And so we divide both sides by 10. We get x equals 1. All right. So, see, we get the same answer there. Again, the reason why I don't like to rely on cross multiplication is because it's only for a very specific situation, and I don't like having students memorize all these different situations involved with math. I know it could be very, very overwhelming. So I try to teach methods that streamline into all sorts of problems. Eliminating fractions with LCD is very helpful, and I hope that this video helped you guys out. Any requests, leave down in the comments. Subscribe for more free math tutoring videos and shorts as well. Hit the like button and subscribe. I really appreciate the support. Thank you guys. Have a good day.